We will now have a brief discussion on acids and bases. What are acids and bases? Common substances, we heard about it. We use acids and bases on a regular basis. In the 7th century, the English writer and amateur chemist Robert Boyle first labeled substances as acids or bases according to the following characteristics. Now, this is what he said. Acids taste sour, are corrosive to metals, change litmus red, and become less acidic when mixed with bases. Well, some of these characteristics. Now, do you know some substances that taste sour? Well, citrus fruits have sourish taste, and that is acidic, you see. Now, so acid tastes sour, is corrosive, it can cause corrosion in metals, yes. If acid falls on your dress, it will create a hole in there. It changes litmus to red. Now, this is litmus paper, and acid, well, I think this is an acid. If this is an acid, this should change this litmus paper from blue to red. Let's see if that will happen. Now, can you see it? Yes, I think it has changed to red. Let's look at that one more time. Let me get hold of another one. Well, I have a litmus paper here. Now, how does that look? Yes, I think blue litmus has turned red. So that is one characteristic of acid. It becomes less acidic when mixed with bases. That means the property of the acid property get neutralized by adding a substance that is called base. We will talk about that. Now, bases feel slippery, so obviously soap is a base, is that right? Slippery, have bitter taste. Have you tasted soap? Change litmus to blue and become less basic when mixed with acid. Now, I have another litmus paper here, and see if we can test a solution and see if it is a base. I have a solution here, and this is red litmus, and see what happens to that. It has changed blue. So a base solution changes a red litmus to blue, and an acid solution changes a blue litmus to red. And a base feels slippery, bitter in taste, turns red litmus to blue, and of course when mixed with acid it becomes less basic. That means I have an acid here, base here. If I mix them together, well, it is becoming more and more neutral. You see? There you are. Well, if I try my litmus in there, see if anything happens. You can see blue remains blue. It has become neutral. In other words, this has now become almost water. When a base is mixed with an acid, they two will neutralize each other. In the late 1800s, the Swedish scientist Svante Arrhenius proposed that water can dissolve many compounds by separating them into their individual ions. Well, we have actually seen that. Water can separate many substances into individual ions while dissolving. We know sodium chloride is broken into sodium ions and chlorine ions. When hydrochloric acid is dissolved in water, you get hydronium ions. You remember hydronium ions. So that was proposed first by Arrhenius. Now Arrhenius suggested that acids are compounds containing hydrogen and can dissolve in water to release hydrogen ions into solution. Now here is a better definition, of more technical definition of an acid. So what is an acid? An acid is a hydrogen containing substance that when dissolved in water releases hydrogen ions into solution. For example, you see hydrochloric acid. Hydrochloric acid contains hydrogen. Sulfuric acid is H2SO4. It contains hydrogen. So all acids contain hydrogen. And when these acids are dissolved in water, what happens? Hydrogen ions are released into solution. That's an important property of acid. Hydrochloric acid, HCl, dissolved in water, we have seen this already. What happens? HCl when dissolved in water. Now this means HCl in water gives rise to hydrogen ions and chlorine ions. You see, water will break it down into hydrogen ions and chlorine ions. Why? Because of the polar nature of water. Now, we also said this hydrogen ion will not stay alone. It will go and get attached to a water molecule, H2O, making that whole thing a positively charged ion. Now, that means this hydrogen ion will go and stick to a water molecule, giving this ion called the hydronium ion. An acid solution contains hydronium ions that are H3O+. So that is the characteristic of an acid solution. An acid solution contains hydronium ions. A base, on the other hand, is a substance that can accept a hydrogen ion. You see, an acid releases a hydrogen ion. An acid is a substance that can accept a hydrogen ion. A typical base is sodium hydroxide. In fact, what I have shown you here is sodium hydroxide. Now, caustic soda, we use that very often. Look at the formula for that. NaOH, one atom of sodium, one atom of hydrogen, and one atom of oxygen. NaOH is sodium hydroxide. It is caustic soda, which when dissolved in water breaks into positive sodium ions, and look at this, OH negative ions. It comes out as a single unit. Their oxygen and hydrogen doesn't separate. It stays as a single ion, OH negative ions. Now this is the characteristic of a base. When a base is dissolved in water, OH negative ions goes into solution. So NaOH, when dissolved in water, separates into sodium, that is positively charged ions, and OH negative ions. Now, you must distinguish between the base and an acid. HCl, which is an acid, when dissolved in water, become hydronium ions and negative chlorine ions. Sodium hydroxide, which is a base, when dissolved in water, separates into positive sodium ions and negative OH ion. Now, an acid solution contains hydronium ions, and a base solution contains OH negative ions. Now you understand why an acid mixed with a base neutralizes. The negative ions will neutralize the positive ions. The acid property and the base property will neutralize. Now what happens when acid is mixed with a base? The H3O plus, the hydronium ions, combines with OH negative ions to form two molecules of water which don't have any charge. Look at this, H3O plus OH negative will simply gives rise to two water molecules. Now 4 hydrogen atoms and 2 oxygen atoms. You see, H3 plus 1H, 4 hydrogen atoms and 2 oxygen atoms. 2 water molecules, and the positive and the negative neutralize each other. Now HCl plus NaOH, HCl is hydrochloric acid, NaOH is a base, sodium hydroxide. If you mix the two, now that's what I did actually here. I mixed sodium hydroxide and hydrochloric acid. What happened? It will produce water and a salt, NaCl. Now whenever an acid and a base neutralize each other, a salt is produced along with water. Potassium hydroxide, KOH, another base which is caustic potash. I'm sure you have heard about that. Now is another base, and look at this reaction, HCl plus KOH, hydrochloric acid plus potassium hydroxide will again give you a water molecule and KCl. What is KCl? Potassium chloride, which is another kind of salt. NaCl and KCl both are salt. So neutralizing an acid with a base always produces water and a salt. I can ask you these things in my little test that I give you at the end of each unit. Is that right? Simple ideas. So take note of these very simple properties. Neutralizing an acid with a base produces water and salt. Now, is there anybody, I know you're all young people, but I suffer from hyperacidity. Now, that means my stomach produces more acid than I need. And I take antacids. Antacids are bases. In other words, I am eating a kind of base which will neutralize my acid, which will then produce water and some salt, which is not dissolved in water, which will then be thrown out of the body. So an antacid, a chewable antacid, is actually a base. Let us now talk about strength of acids and bases. Acids and bases come in varying strengths. There are very strong acids, very weak acids, very strong bases, very weak bases. There are gradations in the strength of acids and bases. So acids and bases are classified according to their degree of ionization when placed in water. The amount of ions that are generated depends on the quality, the strength of the acid. Strong acids ionize completely in water. It produces lots of ions. Now, nitric acid. Now, don't worry about these symbols, but this is another kind of acid. Nitric acid, HNO3. Hydrochloric acid, HCl. And sulfuric acid, H2SO4. These are three very strong acids. In fact, our stomach acid is hydrochloric acid. It's a very strong hydrochloric acid. It is very corrosive, and I can feel it. You know, why do people get heartburn sometimes? I used to get heartburn very often, and only my antacids will keep the heartburn down. You see, this corrosive acid, when it gets built up, it can actually come up on the esophagus and corrode it. And that's when you get ulcers and all kinds of problems. So acid is a very corrosive material. It is very good for digesting your food and of course killing bacteria and so on. But if it is too much, it will corrode your system and cause ulcers and give you all kinds of problems. Alright, acids that ionize only partially produce fewer hydronium ions. You remember the hydronium ions? H3O plus, and they are weak acid. Now citric acid, lime juice, is actually an acid. It's a weak acid. Lime juice and vinegar are examples of weak acids. Similarly, a strong base is completely ionized in solution. Sodium hydroxide is a very strong base. Ammonia, NH3, magnesium hydroxide, calcium hydroxide are examples of weak bases. So there are many substances that can be categorized as acids and bases. Some are very strong acids, some are weak, some are very strong bases, some are weak bases, and you can grade them on a scale, and that scale is called the pH scale. So pH scale is used to determine the strength of an acid or a base. The strength of an acid or a base is expressed in terms of a range of values called a pH scale. Now, what is a pH scale? A pH scale is based on the concentration of hydronium ions in moles per liter. You see, pH is actually a measure of concentration. Concentration of what? Of hydronium ions per liter in a solution. It is the hydronium ions that determines the acidity of a solution. So once again, a pH scale is based on the concentration of hydronium ions in moles per liter in a solution. Now here is the description of that pH scale completely. Pure water has an ionic concentration of, what's this number? 10 to the power of -7 moles per liter of hydronium ions, and 10 to the power of -7 moles per liter of OH negative. So pure water is neutral. It is neither acidic nor base. In other words, it has equal amounts of hydronium and OH negative ions. They neutralize, you have pure water. So what is the pH value of pure water? Look at this number. I want you to look at this number. Pure water is neutral, and the concentration of hydronium ions, you see, H3O moles per liter. The concentration of hydronium ions is 1 times 10 to the -7. And its pH value is therefore 7. So this number is that pH value. That is pure water. And now, as you go higher, the acidity increases. So look at this. As the acidity increases, what happens to the pH values? It decreases. Well, it means the pH value decreases, means there are more hydronium ions per liter. Look at 0 pH. Now, the concentration is 1 mole per liter. You see, 10 to the power of 0 is 1. When you have 1 mole per liter of hydronium ions, the pH of that is 0, and that is a very strong acid. Hydrochloric acid is of 0 pH. It's a very strong acid. And an acid that has a concentration of 10 to the power of -1, 1/10 of a mole of hydronium ions per liter, and it has a pH of 1, and an example is stomach acid. You see how strong that is? Stomach acid is very strong, so don't get yourself into a situation where you have more acid than you need. It's very damaging. I know it. I suffer from it. Okay. Well, you know, a lot of overactivity and mental conditions and also some biological conditions can actually cause it. Now, if you come over here, a concentration of 10 to the power of -4 moles per liter of hydronium ions has a pH of 4, and the soda you drink has a pH of 4. That means whenever you drink soda, you're actually drinking acid. So if you have a stomach problem, especially of hyperacidity, don't drink soda. I haven't drank soda for the last 40 years. Anything that has got acid in it. I don't eat oranges, I don't eat any fruits, because all fruits, some degree of acid in all of them. Well, milk is acidic. Alright, if you go down to bases, look at the pH value of sodium hydroxide. The hydronium ion concentration is so small. It is 10 to the -14 moles per liter of hydronium ions. So that has the least amount of hydronium ions. Therefore, it is the strongest base. Its pH is 14. And you can see egg white has a pH of 8. It is almost a base. Baking soda is a base. Tums, what do you take Tums for? I talked about it. Tums is an antacid. It's a base. It's calcium carbonate. Okay, so you understand now pH scale and how the relative scales are used to determine the strength of the acid. Okay, acid solutions have H3O concentrations greater than 10 to the power of 7 moles per liter. Now, I suppose you understand that because of the negative powers, as these numbers get smaller and smaller, the actual value is increasing. Because, look at this, this is 1, this is 1/10, this is 100th, this is 1,000th, this is a millionth, this is 1/trillionth of a mole. Look at that. The concentration of this is 1/trillionth of a mole per liter. So as you go down, these numbers are becoming smaller and smaller. Acid solutions have the hydronium ion concentrations greater than 10 to the 7. That means the pH values are less. You understand that, don't you? As the pH values become smaller and smaller, the acid concentration is increasing. As the pH value gets higher and higher, the acid concentration is decreasing. So basic solutions have hydronium concentrations less than 10 to the -7 mole per liter. A small pH value indicates strong acid properties, and a large pH value indicates strong base properties. Now, Do you ever experience hardness in water? Well, our water in Florida is fairly hard. What makes water hard? Water becomes hard when it has dissolved minerals in it. Now, water made available for domestic consumption in many places contains dissolved ions of minerals, salt, such as calcium and magnesium. You understand when I write Ca2+, we talked about the charge on each of the atoms on each group. You see, the atoms in group 1 will lose 1 electron and become positive, single positively charged. Atoms in group 2 are capable of losing 2 electrons so that they get 2 positive charges. Calcium and magnesium are elements that belongs to the second group. So they both have 2 positive charges. So the drinking water that we get contains a lot of these ions, calcium and magnesium ions, and that is what makes water hard. This makes it harder for soap to lather in such water. For that reason, it is called hard water. Soap will not dissolve in such water easily. Also, when you take bath in it, the bathtub and the surrounding gets mucky very fast if you use hard water, because the muck that is formed around will not wash away easily. Now you test it and see if what I'm saying is true. On the other hand, if you use a water softener, your water becomes very soft and your bathtub will be always clean. Also, hard water will produce a lot of deposit on water taps. If you look at the inside of the water tap, there will be a lot of deposit if the water is hard. That means eventually those deposits can close water taps, causing a lot of disruption, sometimes breakages in pipes. So hard water causes a lot of problems. Now the minerals, there are minerals in hard water, and what do? The minerals in hard water form soap curds so that it is difficult to clean. Now, hard water is very difficult to clean, and that's why the areas around your tub and wash is always mucky and dirty when the water is hard. Now, it deposits scales that clogs plumbing and fixtures. It builds up scales in water-using appliances such as water heaters that require additional energy cost and reduce equipment efficiency. If you have an old water heater and when you want to replace it, try and open it up. If you have been using hard water, there will be a very thick deposit of scales inside there. That means you are spending a lot more energy to heat water in such a water heater, a lot of wasted energy. So it is worth cleaning up the water, getting rid of the dissolved calcium and magnesium ions by using a water softener. It's not very expensive. You can actually get one installed these days for under $2,000. But that's well spent, because that can keep your bathrooms clean and also your pipes clean and your water heaters clean. And also, you see, if you use a pot for boiling water, suppose you use a kettle for boiling water for coffee. If you use hard water, after some time you can see thick scales are formed inside. All those can be avoided by using soft water. I remember when I lived in England, most of water in London is very hard. So if you use if you use a glass for drinking water, after some time you will see there are scales formed inside that glass. That's terrible. hard water can be softened using an ion exchange water softener. In other words, you can actually use a mechanism by which these ions can be exchanged by some other ions that is not harmful. The hard water passes through a tank containing a high capacity ion exchange resin. Now, this is the equipment that you buy for that about $2,000, which is a tall structure, and the water is allowed to flow through this resin, which contains sodium ions. In fact, you use salt along with it. Now, what it will do is, as the water passes through the resin, ion exchange take place. What kind of ion exchange is taking place? Calcium and magnesium ions attach to the resin beads, while the sodium on the resin is released to water. So, the water that comes out of the water treatment plant will contain sodium ions. It's not really harmful. It doesn't do any harm. It makes the water a little slippery. So, when you treat the water so that you get rid of these ions, the water becomes soft, it becomes slightly slippery. So when you take bath first in that water, you feel that the soap is still on your body. But it's not because the soap is there, the water is a little slippery. But this is a schematic diagram of that. This is the ion exchanger. Hard water containing calcium and magnesium goes through the resin, and you can see as it goes through, the calcium and magnesium ions are absorbed by the resin, releasing sodium into water. That means the water that comes out of it contains sodium. Now, once the water has been flowing through it for maybe about 4 or 5 days, all the sodium ions have been used up. Now, you need to replenish that with sodium ions, and that is called the recharge process. The recharge process, brine solution, that is salt solution, is pumped through the resin, which will then stock up on salt. Now, water is pumped through and washed away all the calcium and magnesium ions, and then recharged with sodium so that your water softener is ready for use again. In fact, you don't need to do anything, it will do everything automatically. Alright? Once a week or twice a week, according to how you program it, it will work automatically. And what all you need to do is, once in a while, give it fresh supply of salt. It is the supply of salt that produces the brine solution. Well, I think I'm going to stop here. This has been a good course. We have now come to the conclusion of Unit 5, and you are ready for the test, Unit 5 test. Okay? As usual, go through the homework and make sure that you have done the practice test, and then do the unit test. Alright? And then there will be a final. The final will contain not many questions, but I will give you 20 questions from all the course. And I want you to go through and learn some of these materials, because I'm going to test how much of science you have learned. How much is your ability in interpreting data? You see, in learning science, you not only learn basic knowledge, you learn to apply this basic knowledge in solving problems. So I'm going to test how much of the skill you have acquired. Alright, well, I will get back with you through email or some other means, or if you have any questions, don't hesitate, always call me or email me. I will answer all your questions. Well, I hope you enjoyed this course. This has been a very good course, and Thank you for being my student, and I wish you all the best. And if you take another science course, well, Edison offers many more of these kind of science courses, and maybe I will see you for another science course. All right? Once again, all the best. Because